Hi everyone, welcome back. So this time we're going over example 3.2. And what do they want of us? Well, they want us to solve for the magnitude, sense, and direction of the resultant force. And as you can probably guess, we're going to use my beloved, my absolutely beloved, resultant of components method. Okay? That's just the best way to do it. So I'm going to go ahead and do it by hand first, and then we'll just look through the steps to make sure and check my numbers. So how would we do this? Well, first we're going to make these into two triangles. So I'm going to draw a triangle right here, get my horizontal component and my vertical one. Draw a triangle right here, horizontal component and a vertical one. Add my 90-degree angles, make sure I don't forget those. And I'm going to name all the signs. So this will be F2y, F2x, F1y, F1x. Glorious. And now I'm going to start solving. I'll do this one with the slope triangle first. So first off, remember that slope triangles are just ratios. You want to look at the ratio of the things you know to figure out what you don't know. So like F1x, I don't know what that is, and I don't know F1y, so don't use a ratio of those two. But I could use F1x and the hypotenuse. So F1x, okay, over, and that's 350. And that should be equal to the horizontal component of my slope triangle over the hypotenuse component, because it's the same ratio, 12 over 13. And then I just cross multiply to solve for F1x. So F1x would be equal to 350 times 12 over 13. What about F1y? Well, F1y, I can do it over F1x if I wanted to now. I'm just going to do it over the hypotenuse again, because that's just how I typically do it. 1y over 350. It's going to be equal to, well, 5 over 13, because that's the vertical component over the hypotenuse component. We cross multiply, and I get that F1y would be equal to negative, because it is pointing down, 350 times 5 over 13. Okay. Now let's look at the second one. So this time I have an angle, and so I'm going to do trig functions. So I'll start with F2x. Well, F2x over the hypotenuse, well, that's adjacent over hypotenuse. And adjacent over hypotenuse is cosine of theta. So cosine of 60 is equal to F2x over 300. That's the hypotenuse. And I'm going to cross multiply to solve, and I'll get that F2x is equal to negative, because it's pointing in the negative direction, 300 cosine of 60. And let's do F2y now. Well, F2y, if I'm looking at the 60-degree angle, which is over here, that would be opposite over hypotenuse. And opposite over hypotenuse is sine, so sine of 60 would be equal to F2y over 300. I cross multiply to solve, and I get F2y is equal to 300 sine of 60. Okay. So I have all my y components, I have all my x components, and I could solve from here. I would just add them together to get the resulting components and go from there. So let's look at this, and let's check my steps now by actually looking at the rest of the slide. So we break each force into its components. How did I do? I did pretty good there. Did that for F1y as well. Opposite over hypotenuse, which is negative 5 over 13, so it goes up to negative 134.6. That works out well. For F2x, we're using cosine of theta, because that's the adjacent over the hypotenuse, because it'll be negative 150. And then F2y, that's the opposite over hypotenuse. So that's sine of 60. So all these worked out well. Now, having done that, we have to add the y components together and add the x components together to get our resultant forces. So our resultant force in the x direction, our resultant x component, is our sum of our x forces. We add them together, being very careful of the sign, and I get 173 newtons. Our y component, I just add together all the y components, and I get 125.4 newtons. Now this is positive in both the x and the y, so you can tell it's going to be somewhere over here. Just guessing that it's going to be somewhere over here. So the last thing we need to do is figure out the angle. What's the angle to the x-axis? And to figure that out, all you have to do is do the opposite component over adjacent. Tan of theta, since you already know what the opposite and adjacent component is going to give that to you. So which component would this be? Well, that's the x component, and that would be adjacent. Which component is this one? Well, that's the opposite component, and that would be the y. So that would be ry over rx. We're going to get to that in just a second. Before that, let's calculate the magnitude. So magnitude is simply each of my components, I square them, I add them together, and I take the square root. And that's coming from Pythagorean theorem. If I want to solve for c, it's simply a squared plus b squared. Okay, and finally, like I said, that angle, opposite over adjacent, ry over rx, and it comes out to be 35.9 degrees. And you've solved. As you can see, in my opinion at least, this is a much simpler method. Okay, there's a lot less guesswork, there's a lot less crazy equations. It's just, can you remember opposite over adjacent or opposite over hypotenuse? Can you remember that whole Sakatoa thing? Okay, yeah. Let me try to do this right. It's Sakatoa. I always want to say it wrong. Sakatoa. There you go. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. If you can remember that, you can solve any of these resultants of the components method problems. And any problem with vectors can pretty much be broken down to that. It's going to be very helpful for this entire semester, so please try to master that. And thank you for listening. Have a wonderful day. Bye-bye.